Hi everyone, today we're going to be looking at numerical differentiation. For the purposes of these videos, I'm going to do a quick derivation of one of the questions to give a breakdown of how everything works. And then I'm going to do a second video where we're going to look at the application of it. So first of all, we are told we need to derive yi to the third prime. And we've been given what it should be. Now, when you're given it, it really does help. If not, you do have a few extra steps, which I'm not going to cover in this video, but it just involves a bit of tedious work with linear algebra. But we're going to look at this. Now, the first thing we need to consider when we're deriving is what are we deriving? In this case, we are looking at the y prime prime prime. And within the equation, what are our terms? So because we have them, we have got yi plus 2, yi plus 1, yi minus 1, and yi minus 2. And we also have our h and our oh squared. So another thing we need to look at is what is our, we need to consider what is our h, and we'll have to define what that is. And the other thing we need to look at is what is our term over here. This term over here dictates the accuracy that we need to be working to. So, first things first, we have got, because we've got the equation, we have I plus 2, I plus 1, I minus 1, I minus 2. And that's very useful in what we're going to be doing because it defines what equations we need to use. If we've not been given the equation, then we're basically going to have to start working it out bit by bit to figure out which equations we need to form. Because we've been given it, we can jump straight in. So the other thing that we need to look at before we start writing out Taylor series is this value over here. They are asking for accuracy to OH squared. So when we write out our Taylor series, we, as you know, we would have if we're doing our yi minus 1, let's start with this one. So yi minus 1, we land up with yi minus h y I to I prime plus h squared over 2 yi prime prime. Remember that because we're dividing by the factorial, and then we'll have minus h cubed over 3 factorial y to the third prime plus h to the 4 over 4 factorial y to the fourth prime. And that would continue on. Now, you'll notice that attached to each of the primes of y, we have an h term. And what's important to note is we want to have to h squared, and we know that we're looking at y to the third prime. If we look at y to the third prime, I'm just going to go down here. If we look at y to the third prime, we have got an h3. And if we look at what our accuracy needs to be, it's an h2. So that means when we're writing out our equation, we need to expand it up until we land up with something that is OH to the power of, it'll be, let me just do the colors, to the 3 plus 2. So that is what we need to make our accuracy. So what we have here, because remember your OH term is going to be whatever is remaining, whatever carries on over there. So 3 plus 2 is going to be 5. So that means from the fifth term and onwards, we can omit. So that's quite convenient because we've written up to there, but let me just write out the rest of these equations. It's just expanding a Taylor series and your I minus 1, I plus 1, I minus 2, and I plus 2. Those are the series we're going to be expanding. Just to remember, I mentioned what the h was. We have to consider the h. When we're working with actual data, remember that the h, it has to be equally spaced. So whatever your x1, x2, x3, whatever it is, the difference between each of your x terms that you're using has to be equal to h. You can't have one which is equal to 2h, one which is equal to h. They all have to be perfectly equal. So I'm going to now write out the Taylor series expansion. Okay, so we've now got the different equations, and I've pasted in the equation that we're trying to derive below. First thing to note is we can see with each of our y terms over here, we have written out each of the equations above. I have written in the different constant for each of the terms as well, just in color to make it easier to follow. I've also not simplified it, so you still have your 2 to the power of 3, just to make sure that you can see where the pattern is coming from. First things first, we've now got this. What we want to do is we want to start looking at this. We want to start assembling this equation. So we have got yi plus 2 minus 2yi plus 1. Now, we're not going to take the plus 2 and the minus 2 together, because these things typically work well in patterns where you alternate with your plus 2, then your plus 1, and you see it's somewhat mirrored on the other side. You could take the others, but I tend to prefer working like this, just working left to right. So taking those two, that means we are going to be looking at equation yi plus 2 is going to be equation 4. Let's just write this below. So we're going to be taking equation 4 minus 2 times equation, that would be 2. 2 times equation 2. Because we've got yi plus 2 minus 2 equation 2, which is yi plus 1. So if we end up doing that, let's start assembling this. So equation 4, we have 1 minus 2 times equation 2, which is also 1. And that is our yi. Look at our next one. I'm going to plus. Now we're looking at our red terms. Equation 4, we've got 2. And then it's going to be minus 2 times equation 2. Equation 2 has just got a 1, as you can see there. So 2 times 1. Here, and our term that's attached is yi prime. And we're going to continue doing this for each of the terms. So now we're going to look at our green term. We are going to go, again, same thing, 2 to the 4, which is 4 over 2, which is 2, minus 2 times a half, which is 1, so 2 minus 1, multiplied by our constants, h squared yi prime prime. Plus, let's look at our next line. This is now the term that we're interested in, the y triple prime. Open brackets. So here we are looking at equation 4 is 2 to the power of 3 over 3 factorial. So that's 2 to the 3 is 8. 3 factorial is 1 times 2 times 3, which is 6. So 8 over 6 is 4 over 3. Minus, we look at our one above, we can see that it's 1 over 3. I'll just pull up so that you can see. 1 over 3 there, so it's 4 over 3 minus 1 over, minus 2 times 1 over 3 factorial. 3 factorial, 1 times 2 times 3 is 6, minus 2 over 6, which is 1 over 3. And that is going to be our h cubed, y prime prime prime, I. And finally, we're going to look at the green. I'm not going to talk through the arithmetic. It's pretty straightforward, but if you take your 2 to the 4 over 4, over here, you'll end up with 2 over 3 minus, and our other one, which is 1 over 4 factorial, you come out with 1 over 24, but we're timesing it by 2, so that'll be 1 over 12. That is h to the 4, y to the 4th prime. And remember, our OH to the 5, even though that we're minusing one from the other, our error doesn't end up disappearing. It doesn't take on a factor of its own. It just remains there. The only thing that can affect the OH term is h's. So we're still going to be sitting there with OH to the 5. Now, this can definitely be simplified. So let's do that over here. So if we simplify that, we'll end up with, on the left, we'll end up with yi plus 2 minus 2yi plus 1. And that is equal to 1 minus 2, which is minus 1 yi, plus 2 minus 2 is going to be 0, plus 2 minus 1, which is 1. That's going to be green. I'll put the h squared in. H squared yi prime prime plus 4 over 3 minus 1 over 3. We have 1. H cubed y prime prime prime. And then we're looking at our green term, 2 over 3 minus 1 over 12. That if you end up working that out, we'll come out with 2 over 3 is 8 over 12, minus 1 over 12, we have 7 over 12. Let's put that here, 7 over 12. And I'll put this in, plus that times h to the 4, y to the 4th prime. Fit in my i's. And we still have our OH to the 5. H to the 5 term. And let's call this equation 5. So we've considered this. Now, our next equation that we want to consider, we want to look at this over here and this over here. Considering those, we're going to do exactly the same. We're going to take, in this case, it's going to be 2 times equation 1 minus equation 3. So let's write that down. So now we're going to go to equation 1 minus equation 3. And that, now the nice part is we know that, we know when we look at our equations above, that 2 times equation 1, 1 and 2, 3 and 4, they all have the same constants. It's just signs that change. So 1 and 2 share constants, 3 and 4 share constants. So when we're doing this, I'm just going to go through it quite quickly. But you can do this yourself on paper, and you'll see I just can't scroll up and down very easily on this. So when we do the second one, we'll end up with 2 minus 1 for our yi term, yi plus, let's do the red. The red, we'll end up with minus 2 minus, so it's going to be 2 times minus 1 minus 2 for this. And that's h y prime I plus, we have our green term, which is 1 minus 2, and that's going to have h squared y prime prime attached, plus, and we're going to do our light blue now. Our light blue, we'll end up with minus 1 over 3 minus 4 over 3. All of this is just from the algebra of our equation, and that is h to the 3 y prime 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 of I. And finally, we have our bright green, which is 1 over 12 minus 2 over 3. And that is our h to the 4, y to the 4th prime of I. And don't forget your h term, your OH term. O h to the 5. So now, once again, we can simplify this. So simplifying this, we land up with, let me get black pen. So on our left, we land up with 2yi minus 1 minus yi minus 2 is equal to 2 minus 1 is 1. We have yi. Minus 2 minus minus 2 is 0. We have plus, I'm going to put 0. Plus 1 minus 2 is minus 1. Do this in the right color. Minus 1. And that is h squared y prime prime I plus 1/3 minus minus 4 over 3. You come out with 1. Because, let me just find my pen, because minus third minus minus 4 over 3, you come out with just 1. And once again, we know this is the h cubed y prime prime prime. And finally, 1 over 12 minus 2 over 3, we come out with minus 7 over 12. Let me just put my plus in. I am putting plus and minuses next to each other. I should be putting brackets, but I'm not going to. I'm mainly indicating the adjacent pluses and minuses for the purposes of understanding where these signs are also coming from. And we've got the 4 over there, I, plus, and don't forget the OH 5. So now that we've got this, we can call this equation 6. So the last thing we need to do, if we look at the equation that we're given above, we have worked out this side, and we've worked out this side of the numerator. So the next thing we need to do is we need to add them together, and let's see what happens. So if we go equation 5 plus equation 6, equation 5 plus equation 6, we land up with, on the left-hand side, find my pen, on the left-hand side, we will have, will be yi minus 2, yi plus 2 minus 2yi plus 1 plus 2yi minus 1 minus yi minus 2. That's what we have on the left-hand side. Just so that you can see where that's coming from. yi plus 2 minus this, plus this, minus this. And on the right-hand side, it's just as easy as adding the two things up that we've got. So if we have a look here, we've got minus 1 plus 1, so we land up with 0 yi. I'm going to put 0 there, plus 0 plus 0 is still going to be 0, plus our green term. So our green term over here, we have 1 and we have minus 1. So once again, that comes out to 0. Now our term that we're interested in, if you find that this one becomes 0, then you know that you need to go back and double check your working. So here we've got 1 and 1. So that's going to be plus 1. I'm going to write this, h cubed yi to the 3rd prime, plus, and then we have minus 7 over 12 in this term, and we have 7 over 12 in that term, and that becomes 0. Everything lands up cancelling out, except for our term we want. And finally, let's not forget our OH to the 5 term. OH to the 5, remember it's unaffected by constants. So OH to the 5. Now, remember, we are looking to isolate the yi to the 3rd prime. So in doing that, we're going to divide through by the constant attached to it. Oh, sorry, I just noticed we had 1 and 1 in both, so that means we have a 2 over here. Because we had the 1 here and the 1 here. So when we divide through by 2h cubed, we are going to have on the left-hand side, we're going to have yi plus 2 minus 2yi plus 1 plus 2yi minus 1 minus yi minus 2 divided by, I'm gonna keep this in blue, the 2h cubed, and that is going to equal yi prime 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 plus our OH to the 5, h to the 5. Now remember, we ignore any kind of constant, so the 2 doesn't matter, but the h to the 3 does matter. H is the only thing that affects our OH term. So the 3 will cancel with the into the 5, resulting in yi prime 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 plus OH. 5 minus 3 is 2, so we have OH squared. Now we've got our term we want, we've got the error, and we've got over here the thing that we were trying to derive, as you can see here. Anyways, I hope that helped. I'm going to do an application question shortly.